Hello guys, welcome again to this channel, Chemistry by Austin. So today we're going to look at acids and bases. In this episode we talk about all of it, like everything that the acid and bases entails. You learn so much about the acids. They're so brilliant, you love it. Without further ado, let's just dive right into it. So, acid and bases. The first thing you need to do is identify the form. Acids have hydrogen in front of them. For example, we have the hydrochloric acid, which is HCl, and then we have HF. We have then another acid, we call it HC2H3O02. Then hydrogen. It has a positive charge. Acids have a positive charge. Now bases include NaOH, KOH, NaH, and Na plus Hi, which have a negative charge behind them. They always have a negative charge, like for example OH negative. So bases have a negative charge, acids have a positive charge. That's one important thing you should know about the acids and bases: negative and positive charge. So by definition, we can define acids to be substances that release ions into the solution. Acids always release ions into the solution. For example, hydrogen ions in mixed with water, H3O, have a positive charge, like the ions involved when you introduce the acid. Another one is hydrogen plus H2O, H3O. That's the one, right? In that example, we learn how acids will introduce the positive charge into the solution. So that's by definition now what acids are. Now bases, on the other hand, release hydroxides into the solutions. Okay? They release hydroxides into the solution. That's the difference. They release ions, acids, and then bases release hydroxides. You're with me so far? Keep up. This is really interesting stuff, by the way. Really interesting stuff. So we go on to say that acids are proton donors. Acids are proton donors. Now, and bases are proton acceptors. Now, acids donate protons, bases accept protons. For example, HCl plus H2O is equals to ClH3O. Now, this is a congruent. Let me just simplify it. The acid reacts with water to produce a congruent. Now, it will donate the chloride into the water to give it a H3O. Okay? You're with me? You will find that solution. It is pretty interesting. Now, the formula goes like HCl plus H2O is equals to ClH3O. Right? Okay, let's continue. So congruent acid, that was a congruent acid. The result was a congruent acid. The donation part of the acid. Now if we can go into it, ammonia reacts with water to produce NH4 plus OHI. That's a base. The result is equals to NH3 plus H2O, base plus water. So H2O congruent acid adds H plus, which is NH4 plus. You feel me? You get that? You get that part? Let me just go back to it. NH3 plus H2O, like a base plus water, increases the base but pluses an OH negative to it. That's the, what do you call it? What do we call it? A negative charge, because it's a base reacting. So that's ammonia. That's the reaction with ammonia to water. Pretty interesting stuff, right? So a congruent acid is like, can be monitored. Let's say monitored, like it can be observed, monitored with a CB or a CA in terms of acids and bases. Like so, H3O, the charge increases, and negative H plus decreases to negative, right? You get it? Like when they're reacting with water, it goes to a H3O, and with a base it goes to a negative H plus, decreases to a negative, and then this one increases. At this point we're just reacting them with water, but you can learn so much, right? Now you get it. Now you get how they work. Okay, so let's go on. In this acid, H2PO4 with a negative charge, this is like a base. The congruent acid is equals to H3PO4. That's when it's been reacted with an acid. And then with the congruent base, it's HPO4 negative 2, right? This was a base or an acid. I'm pretty sure this was an acid. It's a negative charge, so it's probably a base. When it's reacted, it increases, the congruent acid increases, and the congruent base decreases in negative charges, right? So now you know how they react and the charges that are involved. Now let's go straight into the pH scale. Now the pH scale that is used to determine the acidity, the base or an acid, the scale goes from 0 to 14, where at 0.7 is in the middle. That's what we refer to as like the neutral in acidity. Like if it reaches 7, it's probably considered like a pure water. That's what they call it. The experts call it like pure water. So acids range from 0 to 7, and bases range from 7 to 14. Now the pH is equals to negative log H3O positive, and the pH plus POH is equals to 14, but this one is the bases, right? Pretty tricky stuff, but you need to keep up. Don't worry, this is meant to like broaden your horizon, like get you like smarter. After this you'll be like straight up interested in intelligent in chemistry. So this is the episode of acids. You love it. Okay, where do we go on next? So H3O positive is equals to 10 negative pH. Like this acid, after it's been reacted with water, has a charge of negative 10 pH. Well, that reaction is interesting. H3O plus is equals to 10 negative pH. You love it when you get it. So, next we choose to look at the strong acids and weak acids. There are strong acids and weak acids in chemistry. We learn about the strong acids, which strong acids 100, like they ionize 100%. That's why we call them strong acids. They ionize 100%. Weak acids partial ionize, like just a little bit, like 5%. They say it's 5%. Strong acids 100% ionize. Weak acids partial ionization, which is 5%. So some of the examples of the strong acids are hydrochloric acid, bromine, and hydrogen. Like, okay, nitric acids and procylic acids. Those nitric acids, hydrochloric acid, and procylic acids, and brominic acids, those are strong acids. Now when we go to the weak acids, the ammonium and cyanic acid, nitric acid, and sulfuric acid, they are not that strong. They're weak. Nitric acid, sulfuric acid, and cyanic acid. Yeah, acidic acid. Ammonium ion pia, around 5% ionization. I probably got that. So when we're dealing with oxy acids, it's more acidic. Like nitric acid is more acidic than nitrous acid. Sulfuric acid is more acidic than chloric, and that's more acidic than chloris, which is more acidic than hypochloric acid, right? So let's go to the bases then. Now the bases include like strong base which are soluble and have an ionic compound. For example, the first example are hydroxides, barium hydroxides. Reason is they ionize 100% and give strong electrons. They are strong bases, so they ionize at 100% and give out strong electrons. So the weak bases, on the other hand, are insoluble, right? Strong, soluble, weak, insoluble. They do not ionize that much. They ionize less than 1%. So it goes from 100 from a strong base to a 1%. Those are the differences, right? So let's look at some chemical reactions, okay? So a chemical reaction that we choose to look in chemistry is hydrochloric acid when it reacts with water. When hydrochloric acid is introduced to water, it gives off chlorine plus H3O with a positive charge. Now this is a strong acid which we are looking at. So that's where it comes in. It goes from hydrochloric acid plus water to chlorine plus H3O. It's an acid which gives it a positive charge in the end, H3O plus, right? Right. Okay. Now that we've looked at that chemical reaction, let's look at hydride. Is a strong base which reacts with water to produce hydrogen gas and hydroxide. I think this is a base, it's a strong base which reacts with water to produce hydrogen gas and hydroxides, right? This part you get. At this point you already know this. So strong base always produces a weaker base in terms of reaction. Because it goes negative, it goes like weaker. So this is another reaction for a base. HF plus H2O is equals to H3O plus F negative, right? So when this base HF is reacted to water, the reaction goes both ways. Right? The arrow goes both ways, and it goes H3O plus Fi. Now the congruent, when you're looking at it, acids association concept, like the Ka, let's just call it Ka. The Ka is the acid association concept. Now the Ka can be used to monitor this reaction, the HF plus H2O, which gives you H3O plus Fi. It gives you an equation which goes like H3O plus into brackets Fi into another bracket over HF. Pretty much, you know, the mathematical formula where it goes and then it divides, right? That's the Ka. That's how you look for the Ka value. So Ka value increases in strength of acid increases. Like Ka increases, acid increases, right? Let's keep going. pKa goes down, and the pH is equals to negative log H3O plus. That's a base, right? Ammonia reacts with H2O to produce hydroxide ions, right? NH3 plus H2O is equals to 0H negative plus NH4 plus, right? Yeah. NH3 plus H2O is equals to 0H negative plus NH4 plus. So that's ammonia reacting with water. It gives you NH4 plus OH negative. Bases are so cool, aren't they? So cool. So amphoteric substances result after congruent analysis. So where were we? We had just looked at the ammonia reaction, right? That was brilliant. So after the congruent analysis, you can see like the whole equation. So profound, the ammonia equation. Pretty brilliant stuff. So H2O, this is another equation. We're going to look at another reaction. Another reaction is H2PO4 negative plus HF is equals to H3PO4 plus Fi. Now that's definitely a base, right? That reaction is so cool. Like, you see how bases react. That stuff is so powerful. I like it. You saw that reaction. It's amazing, right? So water can sometimes act like an acid. Okay? Water can sometimes act like an acid. So let's go straight to another reaction then. Since you're catching it easily, let's go to another one. Kw is equals to, into brackets, 0H negative H3O, which is equals to 1 times 10 negative 14, and it's 25 degrees Celsius, right? That was interesting. I like it. Even got the pH. Nice. Must be a strong one, right? Must be really strong. So pH plus POH is equals to 14. The pH is equals to 14. pKa plus pKb is equals to 14 as well. So here we are going to look at the pH scale. Acids and alkalines. We're going to discuss the acids and alkalines. So pH scale measures them on from a scale of 0 to 40. Substance neutral is pure water. Now the acid found in the stomach that kills bacteria has a pH of 2, and acid rain has a pH of 4. These are acids. The stomach is pH 2, the acid rain is pH 4. It's a bit stronger. But alkalines, for example, the washing liquid that we use in our houses have a pH of 9, and the bleach we use to bleach like the bathtub, the toilet, the sink has a pH of 12. Bleach is really strong. It seems to be a base. So how do we measure this? We measure them using an indicator which changes color. Now, I know in school they taught you like using the, what's it called? That something. I'm forgetting the name. They taught you using that to test the acidity in bases, right? But in here, which is more advanced chemistry, I'm going to teach you how to use an indicator. It's a tool that is used to measure the acidity. Let's go on. So a wide range indicator, for example, chemical dyes. Now pH meter electronic device dips into it to measure. It's like a device which you can hold in your hand, which has like a string and then like a tampon kind of thing, which you dip into the acid into the beaker, and then the device will just tell you, right? It will just tell you that this has a pH of like 14 based on the acidity of the acid, right? Right there. Let's go on. So we can define an acid again, because we can never be too thorough, as any substance that forms an aqueous solution with a pH less than 7, leaks hydrogen atom into the water, right? There's no need to repeat that. So I'm not going to go that. You know about that stuff. Okay, I'll just do it. So an acid can be defined as any substance that forms an aqueous solution with a pH that's less than 7 and leaks hydrogen. So we've just seen the definition of acids the second time. Let's go straight to the bases now. So the bases can be defined as substances that give you a pH that's greater than 7, right? Basically. You're an expert now. So alkaline is a base that dissolves in water to form a solution with a pH that's greater than 7 hydroxide ions, right? Alkaline is a base that dissolves in water to form a solution with a pH that's greater than 7. Okay. In one of our final chapters in this episode, we look at neutralization reactions. Neutralization reactions produces salt and water every time. For example, when hydrochloric acid reacts to sodium hydroxide, they give you NaCl plus H2O, which NaCl is a salt, right? So hydrochloric HCl plus NOH hydroxide, sodium hydroxide, NaCl plus H2O, salt. You think my chemistry teacher should have been this thorough? Anyway, let's go on. Hydrogen ions always show neutralization reactions. Hydroxide ions. Oh, this is the equation for it. Hydrogen ions and hydroxide ions. Like H plus OH negative is equals to H2O. That reaction gives you water. I wonder if it's water. So common acids and bases include hydrochloric acids, which the formula is HCl, sulfuric acid H2SO4, nitric acid HNO3, and the bases are sodium hydroxides NaOH and calcium carbonate CaCO3. Bases usually include hydroxides and carbonates, right? And that's all we have for today, folks. That was the acid episode. I hope you liked it. I hope it was more informative. I hope it broadens your horizons, as we spoke of. Try to stay woke. Fuck with things that are really interesting, intuitive, things that are really majestic, great things, for instance me. Yeah, until I see you again, folks. Austin.